Hey, Wagwan, it's Mr. Garfield here, and today we'll be looking at a CAPE Pure Mathematics Unit 2 question, right? This is in Module 1 of the syllabus, that's Complex Numbers and Calculus 2, okay? So here we have an integration question from the 2017 past paper, and it says we are to calculate the integral from 0 to 1 of sine inverse x divided by the square root of 1 minus x squared with respect to x. All right. So here we have a definite integral, right? Because we have the limits involved. So what I'm going to do is to find the definite integral first, right? That is where you have the plus c at the end after you integrate. And then I'm going to find this integral, which is the definite integral. Okay. So let me write my solution here. Solution. Right? So what I'm going to do is to say let I1 be equal to the integral of sine inverse x, right? The integral of sine inverse x divided by the square root of 1 minus x squared dx. And I'm going to let I2 be equal to this integral above, right? So I2 is going to be equal to the integral from 0 to 1, right? From 0 to 1 of sine inverse x divided by the square root of 1 minus x squared with respect to x. So I'm just doing this because I don't want to keep on writing the integral of this and the integral of that every minute, right? So I'm just going to see the definite integral is I2 and the indefinite integral is I1, all right? So let's just find I1 first. So I1 is equal to, what is I1 equal to? Well, before we actually calculate that integral, let us look at the numerator and the denominator. Do they have anything in common? Right? Is there any relationship between them? So let us look at the derivative of sine inverse x. All right? When you differentiate sine inverse x, what will you get? You should know that when you differentiate sine inverse x, you get 1 divided by the square root of 1 minus x squared. All right? Good. So what we actually have here now for I1, what we actually have is the integral of sine inverse of x multiplied by 1 divided by 1 divided by the square root of 1 minus x squared. All right, so I hope you can see that. Good, great. So we realize that what we actually have here for the integral is we have some function of x being raised to a power, right? So what I'm actually saying is that the sine inverse of x is being raised to a power of 1 here, and we're multiplying that function raised to a power by what? We're multiplying it by its derivative, right? That's f prime. Good. Now, any integral of this form is equal to the function f of x raised to the power of n plus 1. So whatever power is here for n, we just add 1 to that power. right? We just add 1 to that power there, and we're going to divide that now by n plus 1, right? The same power, plus my arbitrary constant of integration c. Okay? So following that rule, I can now say that I1 is equal to, I identified that 1 over the square root of 1 minus x squared is the f prime, right? In my rule here, and my function f of x is sine inverse x, and it is being raised to the power of 1. So the rule says you add 1 to the power, right? So what I'm going to have now is the sine inverse of x being raised to the power of n plus 1. So the power is 1, so 1 plus 1 is 2, all right? So what I have is the sine inverse of x being raised to the power of 2 divided by the same power 2 plus my arbitrary constant of integration c. Okay? That is I1. Good. Let us now find the I2, which is the definite integral. That is the one that they asked us for. All right, so I2 is going to be equal to, we already integrated sine inverse of x over the square root of 1 minus x squared with respect to x, and that is sine inverse of x all squared divided by 2 plus c, right? But remember, with a definite integral, you don't have to write the plus c. So we're evaluating this here from 0 to 1. Okay? So I hope that was clear. So you know that once you reach this step now, it is the upper limit minus the lower limit, right? So I2 is now equal to, when we substitute the upper limit, that is when x is equal to 1 here, right? We get the sine inverse of 1 all squared divided by 2, right? That is what we get there. Minus, we substitute the lower limit, that is when x is 0. So we have the sine inverse of 0 all squared divided by 2. All right, divided by 2. Great. I2 is now equal to, so you can just put this value into your calculator, right? The sine inverse of 1 is actually pi over 2 radians, all right? So that's pi over 2. I remember that we're squaring, all right? We're squaring that, and we're dividing by 2, right? Minus the sine inverse of 0 is 0. So 0 squared is 0, and 0 divided by 2 is 0. Okay? Good. Let us now simplify this now. So I2 is equal to, I'm going to square pi over 2. So when I do that, it means that I have to square the numerator and the denominator of that fraction. So what I'm going to have now is a pi squared over 4, right? I'm going to have a pi squared over 4. And remember now that I'm dividing all of this by 2, right? I still have my 2 in the denominator here. All right? So I2 is now equal to, I have a fraction divided by a constant. So it means that the denominator will actually come here, right? In front of the 2 being multiplied. So what I actually have now is I2 being equal to pi squared divided by 4 times 2. All right? Pi squared divided by 4 times 2. Okay? Good. So I can now say that I2 is equal to pi squared divided by 8, right? Pi squared divided by 8 radians. So I can now say, therefore, the integral from 0 to 1, of sine inverse x divided by the square root of 1 minus x squared, that is I2, right? That is equal to pi squared divided by 8, all right, divided by 8 radians. Okay, so that is my answer for this past paper question. The answer is pi squared over 8. Okay, good. I hope it was helpful. Okay, if it was, please ensure to like up the video and comment down below. All right, and please ensure that you are subscribing to the channel. Okay, I am Mr. Garth Reed, student ambassador in the University of Technology, Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.